bring you like an exciting topic, a part of containers in Azure. So we learn how to work with Azure Kubernetes service. So basically, I work as an architect in intelligent cloud and automation. So I'm a C# Corner MVP, MCT, and a published author. So that's a brief introduction on me. So I'll quickly jump into the agenda. I think we're good to start, right, Nandadeep?
Yes, we are here.
So I'll quickly jump into the agenda. So like we have a lot of things to cover in the next 1 hour or 45 minutes or so. So without wasting time, let me jump into the agenda. So we'll start with an introduction to containers. So I'll tell you like what exactly containers are and why do we need containers in this modern development paradigm. Then we will deep dive into Azure Kubernetes service. We'll see like why we need Azure Kubernetes service in the first place and how it is related to containers. Then we will have a quick look at the Kubernetes service architecture. So, or in more specific, Azure Kubernetes service architecture. So whatever will be like covering here, like it would be more on the managed Kubernetes service on the Azure platform. Then we will talk about the big picture, like how a developer and can use different services and host his application in the AKS and how the user can consume it. So like we'll see that big picture. And finally, we'll have a demo. So in the demo, like we'll spend most of the time in the session. For the first 30 minutes, we'll be speaking about all these theoretical concepts or we'll try to wind up as much as possible. Then we will spend a good amount of time in the demo, learning actually how exactly we need to do the things. Okay. So coming to containers. So let me just walk you through what containers are. So basically containers are nothing but they're a kind of a virtualization, or rather I would say like they're operating system level virtualization. So in this case, what happens is, so we have an infrastructure. So when I say infrastructure, like we'll have our physical data centers or a physical virtual machine or a physical machine or a virtual machine. So on top of that machine or the infrastructure, we'll have the operating system installed. And on top of that operating system, we have a software called as the container engine. So if you're familiar with Docker, so Docker is an example of a container engine. And what this container engine does is it virtualizes the underlying operating system. So what this container engine will do is, so it will run on top of this operating system and it will keep virtualizing your underlying operating system and spin up multiple containers. Containers are nothing but they're compute units where you can host your applications. In this particular example, you can see here there are three applications running here: app 1, app 2, and app 3. So each of these are containers. App 1 and app 2 and app 3 are running in three containers on top of the container engine. The role of the container engine is that it is virtualizing the operating system. And this operating system is nothing but it is running on top of this infrastructure. And this infrastructure is nothing but it is your physical hardware. Okay. So when we see this container engine, so I already told you this is nothing but Dockers. So you can imagine, so if you've already hands-on in containers, so you can imagine like why we need to install a Docker on our system to get the containers running. That is because when we install the Docker, so what happens is we get this container engine that virtualizes this operating system. Okay. So this was the story about the operating system level virtualization and introduction to containers. But again, so why the container is popular? Because when I talk about virtualization, you'll tell me, right? We already have virtual machines, right? They're also virtualization concepts. Then how is this different? So how the operating system level virtualization helps us? The answer to this is it is lightweight. So operating system level virtualization is lightweight because it directly virtualizes the underlying operating system. When we see the virtual machine, so what we have? We have the underlying data center or the hardware. On top of that hardware, we have an operating system. And on top of that operating system, we have what we have is like the virtualization softwares. And these virtualization softwares like Hyper-V or something. So like what they will do is they will virtualize the entire hardware stack. Okay. So when I say that they're virtualizing the hardware stack, that means they'll be virtualizing the underlying infrastructure at a place, not just the operating system. They will virtualize the entire hardware. In this case, the hardware is not getting virtualized. It is just the operating system that is getting virtualized. And when I'm virtualizing the hardware, that means I'm spinning up a new system in place that also has an operating system. So when we say a virtual machine, the virtual machine consists, it's definitely it's a virtualization of the underlying hardware, but that virtual machine also consists of the operating system of its own. Okay. So when we are hosting an application on top of that, so we have the virtual machine on inside the virtual machine, we have its own guest guest operating system. On top of the guest operating system, we have our software installed, right? So that is how it looks like. But in case of the containers, we don't have any operating system inside this containers running. It is already taken care by this container engine. So it is lightweight, as we are just virtualizing the operating system, not the entire infrastructure, and we do not contain any kind of OS to run any of these applications inside the containers. The most important thing why it is very useful is like it is very much portable across environments. Okay, let me give an example of what I mean by this. So I will take you back to way back to 2005 when I started my job, like my career, like in IT. So on my first day, my boss asked me to set up a few of the softwares. He gave me a big manual and he gave me a system. So this system had nothing. It just had the operating system. And I followed the manual and I did a lot of setup and I could host the application on that setup. And the entire process took around maybe like say like 4 to 5 days, because that was pretty complex application. So I had to like put all different hosting softwares. I had to configure IIS. I had to like put in different depending softwares. Then I was able to host it. Okay. So it took a lot of time. But had we had container at that point of time, it was not there at that point of time. But imagine had we had container at that point of time, the advantage we would have got there is, like what I could have done is I could have created a container. So container image. So how it works is we create a container image, and inside that image, I will have all the depending software installed. Okay. All the hosting environment packed into that. So the container image, what it will contain is like all my depending softwares, all hosting environment, everything packaged into it and kept it somewhere in a centralized repository. So at that point of time, if my boss would have asked me to like run this application on a system, so what I could have done is I could have installed the Docker engine. Okay. I could have pulled that image and I could have run that image as a container. So everything would have happened in just 30 minutes. So because I'm not setting up any kind of environment, I'm just installing this container engine, this entire application and its dependencies are already baked into that image, and that image I have in some kind of repository. So that is the advantage I will get. So with containers. So when we have a container, so what we do? So we create a container image, we put in all the dependencies, everything, and then we keep it in a centralized repository. Suppose I have build it in the dev environment and have it in the repository. I will go to my production environment or a UAT environment. And in that environment, I need not do any kind of environment setup. I just need to pull that image and run it. That's it. And I'm done. So that is as easy as this. But yes, like your next question would be how to handle like the configuration settings and all. Because in production environment, we'll have different config settings. In development environment, we'll have different config settings. So how am I going to handle all those things? So the answer to that is yes, we can handle, we can externalize those kind of settings, and we can definitely take use of it in our like when we are actually designing our container ecosystem. Okay. So now let me come to Kubernetes. So I hope we all got the containers right. All of you are with me, right?
Yes.
Okay, cool. So let me come to why we need a Azure Kubernetes service. Okay, I said that we have a container, we have all the dependencies inside that. We just need to pull that container and run it in a target environment without having to do lot of things. Okay, but when we say a container, it's a single compute unit, right? So when a single compute unit runs, we pose a lot of problems. Let me give an example and try to explain you what I'm trying to tell. Suppose I have a scenario like I have an application, so which has a web tier, a UI tier, and a database tier. All these are like loosely coupled tiers, so they're not tightly coupled monolith applications. And each of these tiers are running in a container. Say like I'm having a web container, I'm having a database container, I am having a UI container. For example, the UI container is working fine, the database container is working fine, but your web container goes down. So what will happen? Even though the other two containers are up, but the web container is going down, or the container where the business logic is there is going down, the other two containers are also impacted because they talk to each other, and together they actually achieve a business functionality, right? So my business fails, my environment goes down, right? So that is a challenge. So how am I going to handle that? Another scenario is like, suppose again, like I have this 3-tier application, each of the tier is in a container. So suppose like the UI container like experiences a heavy load, but my business container doesn't like explicitly have a heavy load, and my database again has a heavy load. Like for some reasons, like some reasons, we have this kind of a topology. So how am I going to like scale each of these units independently, right? For that, we need to do a lot of coding, logic, and all, so that each of these units, they can scale independently, right? So these all are the challenges when we talk about the containers. So, and when the number of containers grows, so I just spoke about 3 containers. What if we have 10 containers? And in real-time scenarios, you'll have applications like, suppose you are adapting a microservices fashioned applications. You'll have at least 40 to 50 applications at bare minimum running in the application components running inside the containers. So you need to manage all these 40-50 containers. You need to manage like the communication among these 40-50 containers. You need to make sure that the communication happens securely among these 40-50 containers. High availability, reliability. If one of the container goes down, I should have a replica immediately sprung into action and tackling to the problems, right? So how am I going to address those kind of scenarios? The answer to this is Kubernetes. So basically what a Kubernetes is Kubernetes is nothing but it's a containers orchestration solution. So what I mean by this container orchestration solution, it's a pretty simple thing. Like suppose I have like 4 or 5 containers running in my environment, and I want to manage and handle that. So let me go back to my example. So in which I had 3 tiers, like UI, web, and UI layer, web layer, and again like my backend database layer. Okay. Suppose these 3 containers, if and I am putting it inside the Kubernetes platform. So what will happen is, if one of the containers, say like the web layer, goes down, immediately what the Kubernetes platform will do is, it will spin up another alternate container to this container that went down. So as soon as the web container goes down, so another container will spring into action. It will replace the container that went down, and it will complement to both of the other containers, and it will start working. So my business will not be down. And every time, like you can have replicas, like maybe like 2-3 identical containers, they're running together. So if one of the container goes down, other 2 containers will be there to serve it. So maybe for in that case, like I can have a 3 web layer, 3 UI layer, and 3 database layer. Even if one goes down and the other 2 are there, like in the web layer, I have 3 containers. One of the container goes down, the other 2 containers inside the web layer can still like solve the purpose, and they can uh, handle the traffic, the incoming traffic that it is coming. Okay. So like, and also like in the background also, it will self-fill the other container, and again the 3 containers will come back to action. So that kind of management is done using this orchestration softwares, and Kubernetes is one of the orchestration solution provided from Google. And there are other solutions also, like Docker Swarm and all. So I'm not discussing here. We'll focus on Kubernetes here. And why we need a managed Kubernetes on Azure platform is, or rather, like what exactly managed Kubernetes is. So I'll tell you, like when I say Kubernetes, Kubernetes has 2 components. One is the master node, and another is the worker node. Okay, the worker node actually runs the containers, and the master node controls this worker node. So whenever I'm creating any kind of service, or rather, whenever I want to create a Kubernetes environment, so I need to install both the master node as well as this worker node. I need to have both the components ready, and it is not that simple. It's very hectic and very challenging as well. So it takes a lot of time to set up this master node as well as this child or the worker node. So in like when I did this for the first time way back in 2016, so it took me around say like a week or 2. So we were 2 resources we were working on setting up the cluster. So it took us to a week or two to figure out like how to do it. And definitely it was for the first time we were doing it. So we had challenges, but on average, you can assume that it will easily take time, like 3 to 4 days or 1 week to set up a cluster. And again, it will depend on the based on the complexity of your application or your Kubernetes design. Okay. So to reduce this complexity, so what is this cloud platforms have come up is with managed Kubernetes. So what it does is they abstract the most challenging part of the setup, that is the master node. So when we create a Azure Kubernetes service, which is nothing but a managed Kubernetes service, so what it will do is this Azure Kubernetes service will create this control plane or the master node. And the master node is the most complex thing that you need to set up. So when you are using the master managed Kubernetes, you need not worry about the control plane. So or the master node. So the master node is being set up by the Azure platform or the underlying platform where you are creating it. You need not worry about managing those master node component. Everything is taken care by the cloud provider. You just need to focus on building your application, bringing into your nodes and hosting and running it on the nodes or rather the worker nodes. So you still like you can access the worker nodes, you can manage your worker nodes, but coming to your master node, you have no control over it and it is managed by the underlying Azure platform. That is the reason why it is called as managed Kubernetes. So few of the other things that we already discussed is like it reduces the complexity and the operational overhead of managing Kubernetes. That is like suppose see like you have set up a master node, right? Suppose like you are not doing a Azure Kubernetes service or any kind of a managed Kubernetes service. You are setting up this master node manually. So like what will happen in the manual in this case, you will have to patch your servers. You have to like you need to see that if the server goes down, you need to again like bring up another alternate server or fix the things. So you need to make sure that this master node is always up and running. So there is a lot of operational overhead involved here. To reduce those operational overhead, you can go to this managed Kubernetes or rather the Azure Kubernetes service, and you need not worry about the master node. You just need to focus on the worker nodes. So I have already spoken like very popularly we run the microservices kind of applications on AKS, but it's not just microservices application. You can also run a monolith application there or a single small unit of application also on this AKS thing. And the best part is that there are multiple ways to create AKS or Azure Kubernetes service. One is through the portal. Another is like Azure PowerShell, Azure CLI, ARM templates, even Terraform. So in my project, so we have we are managing all the things through Terraform. So like we use Terraform to spin up clusters and all. So that is how it is. So there are different options to work with Azure Kubernetes service. I hope by now we got like what AKS is and containers is. So let me move to like the architecture of Azure Kubernetes service. So normally, so when we see this, so it has two major components. One is the control plane and another is the nodes. So the control plane is nothing but it is the master node. So like we call the master node as the control plane, and it controls all the nodes or the worker nodes. This node 1 to node 4, what you see here are the worker nodes, and inside these nodes the containers run. Okay, so how it happens is we as a developer will build our, I told you, right, we build our container image and keep it in a centralized repository. So in this case, we have a container, we can have a container registry that can either be an Azure container registry or like any Docker registry or any kind of a public registry which is compatible with the Azure Kubernetes service. We can keep our images here and we can instruct the control plane to pull the images from the container registry and run it on these nodes. Okay, so just mark the sequence. It's very important. So as a developer, we build the container image, keep it in the container registry. Container registry is nothing but the repository of the images. Then as a developer, we instruct the control plane to pull the images from the container registry and run on each of these nodes. Okay, so this is how the overall architecture looks like. So two components majorly, master node and the child nodes or the worker nodes. Okay. Now let us do a deep dive of this part, this control plane, how a control plane looks like. The control plane looks something like this. So API server is the one with whom we normally interact. Okay. So what we do is like whenever we issue any command to this AKS or our Kubernetes cluster. So there are different ways, like we can use kubectl commands, we can do the things to Helm charts. So there are so many options available. So in today's session, we'll be using kubectl commands. So remember, so whatever kubectl commands I'll be firing, I'll be doing it through this API server. So as the end user or as a developer, you will be interacting always with the API server, instructing the Kubernetes to do the things. So suppose you have built a container and you have kept it here. So what you'll do next is you'll issue an API call to this API server, so that will facilitate this Kubernetes platform to pull that image from the container registry and run it on this specific node. So that is the importance of API server. This is the area like that you can access as a developer from this Kubernetes cluster. This etcd is nothing but it is a storage area. It's a highly secured key value storage area or a dictionary storage area that where actually you can keep secured data in this. And scheduler is nothing but it schedules the nodes on the containers on the nodes. I told you, right, we can have multiple nodes. Each of the node is a worker node. Okay, and inside the worker node we run the containers. So how the containers get scheduled? The job of the scheduler is to schedule those containers on these nodes. So what we do is we provide the information to the API server on how many containers we need, how our architecture will look like, what would be the security and all everything. We have information we are providing to the API server, and the API server will interact with the scheduler and it will work on the nodes. And again, like we have something called as a controller manager. These are nothing but there are a lot of controller managers available. One of the example is the replication manager. Or what the replication manager will do is if one of the node goes down, so it will make sure that another node comes up into action and replaces it. So deployment manager, it takes care of the deployments. So when I say deployments, like whenever you you instruct this API server, so it is the job of this deployment manager to make sure that the application or the container image gets the container gets dispatched you through this scheduler to the right worker node. So that is the role of the controller manager. So there are a lot of different kind of sub managers that are available under this controller manager. Then we have the architecture for the worker node. This is how the worker node looks like. So we have a kubelet. Kubelet is nothing but it's the agent. So it's a virtual agent, or rather I'll say like it's a agent that is installed on this node, and this agent will make sure that this worker node is able to communicate with the control plane. So this agent facilitates the communication between the control plane and the worker node. So that is the use of kubelet. So let me tell you one thing. So if you have worked on any kind of continuous deployment environments like Octopus or something, so you must have seen that, right? What we do, we build a system, and in that system we install an agent, right? So that I can enable the communication with the Octopus server. So it is nothing but the same thing. So like here actually we are on the node, we install a software, a kubelet software, and this kubelet, just assume that the kubelet software is nothing but it's just like an agent that facilitates the communication between this node and the control plane. And the pod is the place where your container runs. It can either be container instance or it can be a normal container. So I'm not diving deep into the container instances and containers out here, but just remember pod is the place where your container runs. Kubeproxy helps you in the networking part because your container needs to be networked with the virtual network, right? You'll have multiple containers in your environment. They need to talk to each other. You need to talk to other Azure components. So how it will happen? That is this kubeproxy that takes care of the networking part. And then you have this disk files, like Azure disks and files we need to attach to the pod, because there are there are scenarios where you will need to keep some temporary data or some kind of a volume, like data in the volume, right? Data volume. So how you can do that? That is through this Azure disk files. So it's a big topic. So I'm not covering the entire thing out here. Just at a high level, I'm saying that you can provide a disk or file to the pod where this container can keep their data. So that is the whole story of or rather like I know like I won't be able to do justice to all these components in just in a short span of time, but again like I hope you got how the architecture is and how this Azure Kubernetes service architecture looks like. You guys are with me, right? Or you want me to explain something again?
Yeah, hi Nanda, this is Chandrasekhar.
Okay.
Can you please explain me the role of kube proxy and kubelet? I mean, kubelet I understand, but what is kube proxy? It looks like a single standalone piece.
Huh. So see, it's actually it looks like a standalone piece here. That is how the diagrams depict. But it is one of the major component in the entire node because it's the thing that helps you in networking. So just as think it as a NIC. You have a NIC in your computers, right?
Okay, yeah.
The NIC card that helps you in networking. It's not a NIC, but I'm just giving a random example. So kube proxy is nothing but it makes sure that this node gets available in the Azure Virtual Network.
Okay.
So it should be able to discover other containers. It should be able to communicate with other containers, right? So how it will do it? It is this component kube proxy that gets it done.
Okay.
Again, networking is a big area. I'll give you some pointers towards the end of the session that you can dig in. Okay. Okay, cool. Then if you're getting questions means I know like you guys are with me.
Hey, hi, this is Pramod here.
Hey, Pramod.
I have one more question with respect to that kube proxy itself. How exactly does it function? I mean, does it follow the natting thing, or it directly assigns some sort of virtual NICs to that POS? How it functions?
It's all virtual NICs only. Like it's a big thing actually. So I won't be able to cover the entire kube proxy here. Towards the end of the session, I'll give you an article of mine where I have actually spoken about the networking component, where you can find the kube proxy. All these components, whatever you said, right, the natting and all, everything is taken care by this component only. It's a proxy for the network proxy actually, basically. So all netting,
That's
everything
fine,
is.
but you know, does it use natting, or it just allows pod to communicate external to any other virtual node, virtual host, or external systems directly?
There. Without natting, it won't, right? It won't be able to like that translation will happen. It's part of the network architecture. Netting is there. It uses natting.
Okay.
So that's a very big area actually. I'll give you one article. You can read that. So in that you will see there are different kind of network architectures when we talk about Azure Kubernetes service, basic and KubeNet. So in both the areas, so like netting and all these things are there. There is also a virtual bridge. So many things are there actually. Like I won't be able to cover it in just now, like in just 5 to 10 minutes. So maybe I'll give you that article. You can go through that actually. It's my article only. I'd written. Okay.
Sure. Yep.
Okay. So let me come to the big picture, how it works. So we as a developer, what we do is, okay, before I jump into this, just ignore other services out here. Like we have web app for containers, we have Azure Service Fabric, we have ACI. So all these are nothing but they're capable of hosting containers, just like Azure Kubernetes service. You can build your containers and all these services you can use to host your containers. Okay, so these all are available options in Azure. So we'll only focus on Azure Kubernetes service, just so that you have an idea of the thing. So I have kept all these other three services also. So, and I'll just touch upon that. Azure Service Fabric and Azure Kubernetes service can host actually multiple environment scenarios. And when you have to run just a single container, you can use Azure Container Instance or Web App for Containers. And there is a big story about ACI also. Like this ACI also runs inside AKS as a node. So we call it as the serverless nodes. So again, I'm not getting into those areas. Okay. So let me talk about the big picture. So we have a developer who develops the entire code. Okay, we build the code. So what this developer will do is, once he has developed it, he will containerize this code or this application, and the container image, he will push it to the Azure Container Registry. This Azure Container Registry will keep that container image, and then we will have this Azure Kubernetes service which can pull the container image from this Azure Container Registry, and then it can run it. So this is the big picture. So our role is to build the Docker image and push it to the Azure Container Registry, and then we need to instruct the Azure Kubernetes service that this is this particular image you need to pull and orchestrate it. So this entire flow we will see now. Now I will be building the demo. So this entire flow we'll see now. I know we'll be having a lot of questions as of now. Like I could sense it's good that we got 2 questions, and I'm happy that. Sorry, just 1 minute. And it's good that we could do a lot of I mean to say, you guys are with me. I could sense it. So let me get into the demo and check the things. What I have done is, before the session, so I have already created a application. Actually, I call it as AKH demo. So let me open the solution. Okay, I have already created this application, and I have this Docker file. So when we create web application in this Visual Studio, you can easily enable Docker support. So I have done that. But if you're from some other technology background, don't worry about that. What you should focus on only on the Docker file. And if you're from the .NET background, just remember that in the Visual Studio, we just need to do a right click, and then we can go to the add, and here you will get the option of add Docker support. Since I've already added it, so the Docker support is already added. Else you can click on this add Docker support, and when you do this, so this Docker file gets generated. And also I would like to highlight, ignore this Docker compose thing. So since it's a Mac Visual Studio for Mac, so that is why this Docker compose is there. But if you're working on the Windows environment, this won't get generated. It is just this Docker file that will get generated. Okay. So what this Docker file does is, the Docker file helps us in containerizing our application. And I told you, right, we are packaging everything out here. So how do we do that? So first, if you see here, we are pulling a standard image from the repository, from the mcrmicrosoft.com registry. So this is this image that will be packaging actually. So will be used for the packaging. Why? Because it is slim. And I'll ask you this question immediately after I cover this thing, why I'm going for this image as the base, why I'm not going for the other image that I'm using for the build. So this image that I'm using for the build. I'm pulling this image from the registry. I'm setting up the source as the work directory. Then I'm copying the csproj file to my build work directory, and then I'm running this restore. I'm doing a .NET restore. That means I'm restoring all the packages inside this source working folder inside this build image. And then once I'm done with that, then I come to the publish. So all these things, definitely this Visual Studio stuff, we need to package it, we need to build it, all these things. Then what we are doing here, this build, then we are publishing it. And here actually, when we are publishing, we run this publish commands. These all are .NET commands. If you are having any Java applications, then you can write your similar steps for your build and the publish, or any other Python or other applications. You can have your own commands here and build your Docker file. So once I published it, so the next thing is that I need to copy everything to this base image. So I'm using this base as the final image, and I'm copying everything, the entire published folder, into this base image, and I'm doing it as such. So one quick question, you can see here, I'm using 2 builds, right? One is slim, and as well as another is a normal build one. Why did I use 2? I could have published this build image also, right? Anyone can answer? why I went ahead and made this as the final, this slim one, not this buster one. Any guesses?
Maybe it would require less resources, or it would not consume the more resources of the operating systems and all those things.
Yes, that is one of the reason. And another main reason is, if I go back to my slide, you see here, so like it's all a network operation, right? I push the Docker image to the Azure Container Registry. It's through the network. And again, my AKS is pulling that Docker image from this Azure Container Registry. So there are so many network operations happening. For that, my image has to be lightweight, right? The slim image is lightweight. That is the reason why we are using this full-fledged environment to build and package my application. Then I'm putting everything in this slim image. Okay, so that is a story about this Docker file, and this Docker file will help us in containerizing the things. Now let me run few commands, containerize it, and show it to you. Okay, let me go back. Where I am, my desktop sessions, AKS demo. I have my Docker file here. So let me open a command prompt. So new terminal at folder. Okay. So also let me open the I have actually have the commands handy with me so that we don't waste time in errors and all. So I'll just make it a bit big so that you guys can read it. Let me maximize this. You can either use PowerShell or your command prompt also. Okay, either for this as a prerequisite, you need to have Docker desktop installed on your system. So you can install the Docker desktop from Docker Hub. You can have the PowerShell as well as your command prompt that you can use. Or if you're using Mac, you can use the Mac terminal like I'm using. So what is the first step? The first step is I'll come to this step later. So the first step is I need to build my image, right? So let me build it. So this is the command that will help me in building the image, like docker build -t my demo app :demo, and this dot is very important. That says that whatever Docker file I find in this registry, or rather like this directory, sorry, in this directory, whatever Docker file I'm finding in this directory, please build it. This dot signifies that. So let me do that. Okay. So I think I had built it before, so it picked a lot of things from there. The image was already there, so that's why the build happened quick, but it takes some time. Okay. Suppose that, let me see the images, like what are the different images you have here. So you can use this Docker image ls, and you can see this image, right? Okay, let me do a prune so that I can walk you through from the beginning. Prune will clear all the images and we can start from the scratch. Prune is the command to delete all your existing images. So now if I see Docker image ls, I have nothing, right? So let me do a clear. Now let me build it. You'll see different steps. I'll give you all these commands, like I'll pass it on to Nandadeep, so he will give it to you, all these comments and all, so that you can have this hands on yourself also. Okay, so now let me see what I have got. So 8 seconds ago, I have created a image, my demo app, like the tag is demo. I'll come to the tag thing when I talk about the repository. Don't worry about it now. Now, let me run this image. Okay. So I've built it, right? I need to test it locally before I need to push it. So how I can test it? How I can run this locally? This is the command like docker run. You can use docker run, and this publish, what it will do is it will map the ATT port of my laptop with the AT port of the container. That means the containers 80 port will get mapped to 8080, and using this 8080 port, I'll be able to access the application. Okay, and this is the name of the container. So let's see that. Okay, now let me go to my the browser, http://localhost:/ I told you 8080, right? That gets mapped to 8080. See, this is the application that we have built. Like it's a case demo, the same one that we built. Actually, I had created. So just before the session, I had created to save time. So now what we have done is we have our Docker image ready. So now we have this. We need to push this image to the Azure Container Registry. I have already created an Azure Container Registry in the Azure portal. I hope you all are familiar with Azure portal, or else if not, then portal.azure.com is the Azure portal address, and you can create any of the container services. Okay, let me do it again. Just by doing a create a resource and going to the containers, and inside the containers, you can create a container registry here. I'm not creating a container registry right away. I have already created a container registry that I will open. I call it as ACR for demo. If you have attended my previous sessions also, like you must have found this ACR for demo, a common registry that I use. I see few familiar faces in the like in today's session as well. So apologies, like this might be a repeat for a few of you. Okay, so you go inside the repositories. Okay, so this is where your all your images will get pushed. Okay, this is your Azure Container Registry. Inside the Azure Container Registry, inside the repositories, you'll have all the images. Okay, and let me show you something. Suppose I want to push anything to this container registry. What I will need is this username. So I need the username. First of all, I need to enable the admin user. So when I enable the admin user, I get this username and the password. Okay, and I need to use them and push it to my container registry. So I will be pushing like my container image that I built to this registry, and once it is pushed, so like it will be available in this repository. There will be my container image listed here. So let me do that. So let me again go back to the access keys. I'll just show you something. So if you see here this password and the username, I'm using it here. If you see like Docker login, this is the command. This is my fully qualified name FQN for my Azure Container Registry, ACR for demo.azure.cr.io. You will find it here. Login server. This name you need to use. Then you have the username. The username is this ACR demo, and the password. This is this V0 this thing. Okay. Now let me execute this command, and now let me push my container. Let me do a clear screen. Okay. Actually, I think I have already authenticated before. That's why like it didn't ask me for the username and password. If you would be doing it for the very first time, it will ask you to provide the username and password. And in that case, you need to provide this username when it asks for the username, and the password is this. So this is nothing but I've copied from the Azure Container Registry access keys section. Okay. Now, post this, what is the next step? I need to push my image. But before that, I need to tag my image to the Azure Container Registry. Okay, this is a very important step that we should never forget. We should always, whenever we build the image, before pushing the image, as a thumb rule, may it be Azure Container Registry or a Docker Hub or any kind of container registry, we need to tag that image. That is the very first thing to this container with the container registry name. So that is what I'm doing here. If you see here, Docker tag my demo app. This is the whole thing. So let me do the tagging thing. So I'm tagging it here actually. It is very important. You should never be missing this step. I have seen people in my team that they miss this step and then they keep on wondering why containers are not getting pushed, and they keep on debugging and all those things. Okay. Now, once I've tagged it, this tagged image will now get shown here. Let me show you Docker image ls. See here. Earlier we just had this my demo app, right? Now we had another tag like ACR for demo.azuresphere.io /my-demo-app, then demo. This will appear. So you need to verify whether it is appearing or not. If it appears properly, then only your tagging is successful. Post that, what you need to do, you need to push the tagged image, not the one that you built, the tagged image, this image, to the container registry. So that's what I'm doing it. I'm using this command docker push as ACR for demo.azuresphere.io /demo-app:/demo. So let me do that. Okay. And it takes some time to push. So while it is pushing, so let me create a Azure Kubernetes service where I can actually run. Where actually. Okay, before that, let me tell you something. If you see here, just now what I performed was this step. Okay, this part I did. So what I did, I containerized my image and I pushed it to the Azure Container Registry. Okay, this part is done. Now what I'll do is I'll create this Azure Kubernetes service and I will orchestrate this container. Azure Kubernetes service. So how I can create? I can go to containers, then click on Kubernetes service. Then maybe I'll use this RG demo. Let me check what I have used there so that things will be seamless. RG demo and AKS demo. I will call my cluster name as AKS demo. Then okay, so we like in virtual machines now very recently Microsoft released this availability zones for high availability, so you can split your nodes among zones. But anyways, this is irrelevant for me. So what I will do now is I won't be using 3 nodes now. If you would have used 3 nodes, it would have split across the nodes, across the zones, just like we had in virtual machines. But anyways, I'll use the node count as 1 because I want to save some bucks. Okay, so then I'm using the default node pool. I'm not getting into what node pools are, but you can assume that node pools are nothing but they're a collection of the similar kind of nodes. For example, if you see here, I'm using the standard DS2 V2. So any of the standard DS2 V2 can be placed in a node pool. So it's a collection of the nodes. So it's a default node. So I'm not talking about the virtual nodes. It's again a pretty big area. So like if you're interested in server Kubernetes, I'll find some past session videos on this and I will share it with you where you can learn these virtual nodes and serverless Kubernetes. Okay. So let me, I think we spoke about networking in a brief, like someone asked me about the netting and all those things. So here actually is the place where actually you can define your networking infrastructure and all these things. Here actually you build the authentication mechanism, then you go to the networking where you can build it. So there are 2 kinds of authentication mechanism. One is using service principal and another is system assigned managed identity. We all know that, right? So let me do this system assigned managed identity because I want to integrate that ACR to the AKS. Because why I need this integration is from my Azure Kubernetes service, I need to access that image from the Azure Container Registry. Okay. So you can very well use the service principal, but you need to run some extra commands to integrate your ACR to AKS, and so that the AKS will have all necessary permissions to pull the images from the ACR. So you need to run an additional command for this integration, Docker command. Sorry, not Docker command, your AZ command. But you can easily avoid that command by selecting the system assigned managed identity, and from the portal itself you can actually integrate it. Let me show you. So let me go to directly to the integrations. You can see here container registry. I will get this option. But if I go here back authentication, I'm using service principal. I go to the integration. I won't get this option. So what I will do is just to save few commands. So I can integrate it in the portal using the system assigned managed identity. I will select my ACR for demo, my container. Okay. I'm not going to demo the container monitoring. Again, it's a very big area. I'm not touching it upon now. So it's a basic session where I want to show you how to work with the Azure Kubernetes service. So I'm disabling it. Then once I'm done with that, so what I will do is I'll review plus create. But before that, let me show you the networking tab. So I told you there is a basic networking option available. There is a advanced networking option available. So like all these things, you can definitely look at it. I'll share one article with you that I had published a few months back in C# Corner that speaks in depth about the networking concepts. So I'm as of now, just remember there are two networking options available, and I've selected the basic networking and integration. I'm integrating with my container registry. Now let me do a review plus create. Okay. Now let me click on create. So it will take some 5-7 minutes to get created. While it's creating, let's go back and check like what happened to our container push. Okay, I can see that the push is successful. So let me go to the Azure portal. Let me go to home, go to my ACR demo, my container repository, and I can see this. My demo app is already pushed here. Okay, I can see this here. So if you see this, so you can see tags. You can have multiple tags. A quick question, like few of you have already attended my sessions previously, and also like I assume some of you must already be working on AKS because it's pretty there from a long period of time. So anyone can tell me what these tags are or how these tags are used? Or anyone can do a wild guess?
Tags are used to
I think those are
identify
used.
or separate builds.
Okay. Yes, that is how we use it. So normally it is not, it is achieving the purpose of versioning. So either versioning you can say or like identifying different builds. So how we use it is how in my architectures, whatever AKS architectures I build or application architectures I build. So how I use tag is, so whenever I'm building any solution or any container for a prod environment, I tag it as prod. When I'm building it for any kind of a UAT environment, I tag it as UAT. So with this, what will happen is someone in the UAT environment will be able to identify this is the UAT image and he'll pull the UAT image and use it. And he won't be messing up with the things. And most of the times also we do a lot of automation, right, in for the deployment. Like we write a lot of infrastructure as a code. So when you have these tags available, so you distinctly know that like which image to pull when. Okay, your code knows. So you can write your code accordingly and you can pull the images based on the tag, based on the image in the environment. For example, you are building an infrastructure as a code solution, and inside that you say that this is for my client X. So I can tag my image as client X, and in that environment, in my configuration, I can say that this is a client X configuration, and I can pull that client X configuration. I can use it. So that is how we use it actually. Like very well said. It is for identifying our builds. So Nandadeep, I'll need another 10 minutes. That's fine, right?
Yeah, sure. Take your time. Yeah.
Yeah, actually, I'm almost done. So I just need to wait for this AKS to get created. So it takes another 3 to 4 minutes.
Yeah, sure. Meanwhile, if you want, we can take a few of the questions. Otherwise,
Yes.
if you want to cover anything from your PPT, please go ahead.
Yeah. So while this is getting created, so I can take up questions, or alternatively, I can also tell you a few more things about AKS so that you can actually go back and check. So if you see here, as of now, what we did was we completed this. We pushed our image to this container registry, and now we are currently building this AKS. Okay, so we are creating this AKS, and the next step will be pulling the image from this container registry and we'll be orchestrating here. Okay, so while this AKS component gets ready, let me show you one thing. Like maybe like you can use it as a Bible when you are working with AKS. like when you are trying to learn AKS. So there is something called like Microsoft has defined a very good AKS learning path. So I'll just show you that learning path that you can follow. Kubernetes learning path. If you search with Kubernetes learning path, you will get it. Okay. So here actually there is a very good white paper that you can download. And here actually it says in 50 days, you can achieve from zero to hero with Kubernetes. So you can start from scratch and you can actually become a hero with Kubernetes in just 50 days. So what I best like is this, like it is a very well planned journey starting from day 1, going right up to day 32. Okay. So you can follow each of these days one by one and don't rush. Okay. Sorry, right up to day 50. Don't rush. Take your time. So it says that this has to be covered in day 1. Then just cover the day 1 component. Then day 2 to day 5, do these videos. This guy. How many of you know Brendan Burns? Okay. Let me tell you. He is the person behind AKS in Microsoft, and you'll be hearing from him directly. So he has very good videos. So I think he's the VP for this AKS thing, Kubernetes thing, like container services and all. So you can see his videos here, where he explains and teaches how to get the things. And this is one of the arguably they're the best videos available on AKS. So you'll find it there. So then you can learn the core concepts, all these things you can learn. And I love this day 1, and definitely you'll also love this day 1. So day 1 is nothing but it's a small story on how Fifi goes to the zoo. It's a very famous PPT, and people tend to love this a lot. Okay. Okay, it's deployed. Maybe I'll just show you this Fifi thing, and then I will go back to the case. Maybe you should follow this path actually. It's a very good path, and it's worth following this path. And in 50 days, you can become an expert. And anyone who joins my team also, I tell them the same thing. Okay, so in this, it's a animated, in a very animated way, it's explained how Fifi goes to the zoo and discovers different AKS components. Because what I told you about AKS is just 2 to 3% of the entire architecture of the entire things. But when you go through this, you'll find a lot of things like deployment sets, daemon sets, what they are, why we need, what is a replication manager. So all these things you'll find it here, and it's really helpful. Maybe you should go through this. Just search with Kubernetes Learning Path Microsoft and go through this document. You'll get a lot of insights out of it. Okay. My AKS has been created. Let me go back to the AKS. Go to the resource. So this is my AKS, Azure Kubernetes service. Now I want to do the other part. That means this is ready. Now I want to pull this image and run it on AKS. Let me do that. Let me open this guy, Cloud Shell. The advantage of the Cloud Shell is you'll have a lot of tools already installed, right? Your Azure CLI, I'll be using kubectl. kubectl is already available here. I need not install any kubectl explicitly out here. Okay. So I'll get it easily using this Azure Cloud Shell. If I would have done these commands very well, you can install Azure CLI locally on your system. You can install kubectl and you can work on it. But here the advantage I'll get is everything is already installed, pre-installed. I just need to open the Cloud Shell and get going. So that is the fastest way of getting the things around. And also not just kubectl or AZ commands. You can also use a lot of advanced commands like hem charts and all. So they also come here. You need not install any kind of hem charts and all here. But one thing, so if you are enthusiastic about learning serverless Kubernetes, so those things you can't try it in the Cloud Shell. You need to use your local because the func in it, all those commands that doesn't work here. Where actually you build your KEDA component. So let's forget that. Anyways, I'll be building a simple cluster, so it should be fine. Okay. So I have opened my Cloud Shell. So what would be the first step? I need to authenticate myself with the Azure Kubernetes service because I'll be working with this Azure Kubernetes service. I will be instructing the Azure Kubernetes service to do some deployments for me. So how I can do that? The first step is I need to authenticate myself. So what is the command? Let's see that. We have this command AKS get credentials. Okay. So this specific command will help me in getting authenticated and get the credentials locally to my Cloud Shell. This Cloud Shell is nothing but it would be running on some kind of virtual machine somewhere. It's a development environment provided on the Azure platform. So now let me run this. Okay, I have already like authenticated before. That's why it's asking again and again for other clusters with the same name. That's why it asked me twice, like it had already created some kind of component. So it's replacing that. Okay. So I have got the credentials locally. What is the next step? So I can see like what are the different nodes available with me. Let me show you. And I told you, right, kubectl is the command. So if you're doing locally, you need to install kubectl locally. Okay, kubectl is the command line utility that you can use to interact with your Azure Kubernetes service cluster. And whenever you are firing this kubectl commands, you are actually interacting with the API server of the control plane. If you see this, if you can relate it, like maybe just I'll open this. You are actually talking to this API server. So when you are issuing this kubectl commands, so these API calls, these are nothing but they are being generated from this kubectl thing. Okay. So let me see how many nodes are there. Kubectl get nodes. Okay, I can see I have one node here because I had created a single node when I created the cluster. If you remember, I told that I want to save some bugs. I don't want to go with the 3 nodes. I just want a single node. Had I created 3 nodes, you could have seen 3 nodes listed down here. Okay, now let me apply or rather install my application to this cluster or orchestrate this application to my cluster. How I can do that? The quickest way is you can actually use this nano editor. Okay, there is something called as the nano editor. You can open that and you can create your YAML. We use normally a YAML file to describe the AKS deployment infrastructure. So I'll show you that YAML file. So you actually open this. You can like create your YAML file and save it. But again, I'll give you one easy way to use it actually. So what you can do is here actually you can open the editor. Okay. Here also you can import, you can create locally and get your files in. So maybe you can use this open file. Maybe I need to check actually how to import it. Okay, here is the command I believe to okay, it's open new session. Here. So you can actually create that file locally if you're not using nano editor, if you're not comfortable with Linux environments, you can create that file locally and upload it. That's what I've done here. So I have created a file locally called as the deployment.yaml, and I've used this thing like upload download files functionality to upload the file. Excuse me. So let me open this deployment.yaml and show you how it looks like. Let me see if I can increase the font or text size and make it large. Okay, it's increasing. You guys can see this? Guys?
Yes.
It's visible, right? Okay, cool. So this is how your deployment YAML file looks like, and it describes what has to get installed on the Azure Kubernetes service. So you can treat it as a infrastructure as a code kind of a infrastructure as a code kind of a file that defines your Azure Kubernetes service like deployment infrastructure. So here we call it like, I'll just touch upon the main things. I say that I need 3 replicas. So what replicas are nothing but they are identical containers. So when I say 3 replicas, that means the application I'll be hosting on a single container. Instead of that, I'll be having 3 containers. So that if one of the container goes down, there will be other 2 containers that can solve the or serve the request, the incoming request. Okay. So that's why you see here like replicas as 3. Okay, and here I have mentioned the image from where to pull the image. If you remember, we had pushed here, right? ACR for demo Azure CR.io, and this is my image name, my demo app colon demo. Let me show here. You see here, right? ACR for demo azure.io, my demo app colon demo. So this is the same thing, the image. Okay, and this specifies like what amount of memory that container will consume from this underlying infrastructure. If I say 100 M, then I need to make sure that the node CPU can actually really provide me this kind of limits, memory limits that I'm defining out here. And I'm opening the container port 80. Okay. So this is how your container will get hosted. But here there are two components, I defined the containers, but how am I going to expose the container to the external world? With this piece of command, I will be able to make sure that till here, I'll be able to make sure that my AKS will be able to pull this image and run it on my AKS cluster. But how am I going to expose it to the end users? For that, I can use service. So if you see here, I'm installing a load balancer service. Okay, there are different kind of services, cluster IP, load balancer, node port. I'm not touching upon all those things in this session. Definitely towards the end, I'll share one series with you that I had published. I have been working on in C# Corner on that, and still it is a work in progress. In that series, you'll find one of the articles. It's already there. So it's around 3 to 4 months old though. So you can find what are the different services available and how you can work on it. Okay, so here actually, see here load balancer service I'm using. So I'm using this load balancer service to expose my container outside to my external world. Then you will have a question, right? What if it's a story about a single container? Like I have a single pod or a single container definition here. What if I have multiple containers here? Like in name my demo app, I can also have my demo app 1, my demo app 2. I can have multiple containers, right? So how am I going to relate that? So how am I going to relate that? Using the selector. When I say that my demo app, that means that it will match app colon my demo app. Okay, I mentioned the selector as my demo app. So what will happen is this load balancer service will get applicable for this selector, and I have defined a selector out here. See, match level, my demo app, match level, my demo app. So it will get matched with this selector, and this load balancer will get associated with that. Okay, so that is how your entire this thing looks like, your YAML file. And this YAML file, you define all of your infrastructure, like AKS hosting, your deployment things. Now, let me actually do the deployment and show you the things. It's a very simple command, kubectl apply -f deployment.yaml. Okay, let me paste this. Okay, now when I run this command, the actual deployment happened. Now let me see what happened to my pods. I said okay, before that, how many containers or pods will be running? So can anyone tell me? We saw that definition file, right? We said that we have 3 replicas. So how many pods can I see here?
I think one pod with 3 Docker process within that.
It will be 3 pods. It will be 3 pods because they're replicas. And in each of the pod, we were actually having one of the containers. We mentioned replicas as 3 means there will be 3 pods running. If you see here, okay, let me just open it again. So if you see here,
one container equal to 1 pod.
Normally see, in a single pod, you can have multiple containers as well. Okay, where you can have a sidecar kind of implementations and all. But for that is a complex architecture and it's a lot of things to handle. So what is suggested is every time you should be having a single container in a single pod. So when I say replica 3 means 3 pods will get created, and inside the replica, this will be the container. This is the hierarchy. See, this is the deployment. Okay, this is the deployment. Inside the replicas, I have got 3 replicas defined, and each of the replica will have one container. I have defined one container here. See, my demo app. I can define 3 containers or more than one container also here. In that case, suppose I have two containers like my demo app 1 and demo app 2 under this container section. In that case, each of the replica will have two containers inside it. So that explains, right?
Yep. Thank you.
Others, you are with me, right? ये ऊपर से जा रहा है.
Yes, I'm with you.
Okay, cool. So let me do a kubectl get pods. So this will show me the pods actually. You see, I have 3 pods running here. 1, 2, 3. That means the 3 replicas that I've defined. Now let me show you. I have also installed a load balancer, right? How I can see that? I can do a kubectl get services, and I can see my load balancer here. And this is the default Kubernetes cluster IP that gets created. Even if you don't deploy anything, this will definitely get created. So like, and this is the load balancer we have deployed actually, my demo app service. And how I can access, and I said that we need this to expose these pods to the external world. So how the architecture is, all these pods are sitting behind this load balancer. And to access these pods, so I can use this external IP. Let me copy this. Okay. Paste it here. Run it. Now we'll see that this application, right? This is the application, right? We containerized and pushed it to Azure Container Registry. Now it has started running inside this AKS cluster. And I'm accessing it this from the AKS cluster. This is the IP address of your load balancer. See, okay. This is the IP address of your load balancer. Okay. So this was all about like, so if I go back to my PPT, so the big picture. So here actually we created the AKS, we created that deployment.yaml file that helped us in pulling this container image from this Azure Container Registry and running it on top of it.